Welcome back to the channel, folks. In this video I'm going to be looking at a growing problem with these things here, disposable vapes. It's estimated now that just in the UK alone there's approximately about 5 million of these things being thrown away every single day, and you heard that correctly, 5 million every single day. Now, inside these vapes, you'll find a lithium battery. So can you imagine 5 million of these batteries being discarded and thrown out every single day of the week? It's absolutely criminal. Have you ever seen the wee blue flashing lights at the side of the road at night? I'm an HGV driver, part-time, and I see them all the time at the side of the road, and I often wondered, I thought it was maybe something to do with the police or something like that, but just seeing these wee blinking blue lights at the side of the road, well, it turns out it's these. When these things are out of battery or out of puff, so to speak, mindless morons are just throwing them out the window of the car and chucking them at the side of the road. It's an environmental disaster waiting to happen. Now, I'm not the first channel to cover these, but I just want to show that these batteries still have some kind of useful life left in them, given the correct conditions. They can be upcycled and used for various applications. So I'm going to attempt to build a kind of rudimentary power bank to charge a phone or maybe power some LED lights with. I will say at this point though, and I need to stress this point, that this is not intended to be a tutorial. It's merely just to show you what can be done with these batteries as an alternative to sending them to landfill. If you don't have any experience with dealing with batteries like this, or with electronics in general, you could very easily find yourself in a world of pain, because if not handled correctly, these batteries they can become dangerously unstable, and in extreme cases they can catch fire. So please do not mess about with them. So the vapes that I'm going to be using for this video are these big bar vapes here. These things, I think I've got a 1700 milliamp hour battery in them. So the first thing I'm going to do is I'm going to tear down one and let you see how I do it, just so you've got a kind of idea how they're put together. I will be wearing nitrile gloves while I'm doing this, because the oil, or the juice, as the companies that sell them call it, it can be absorbed through your skin, and I'll be honest with you, I'm not really fond of having someone else's saliva or germs all over my hands, as well as the vape juice being absorbed through my skin. They're quite simple devices, these though. The oil inside is vaporised by a heated coil, and the coil's activated by a wee pressure sensitive switch inside here. So basically, when the user sucks on the wee aperture at the top here, it creates a kind of partial vacuum inside this chamber, and that pressure sensitive switch detects that change in pressure and activates the coil and heats up the oil that's in the pad, and that's how you get the vapour coming through the vape itself, through the wee hole there. So some of these devices work based on the amount of puffs, or the amount of times the user sucks on the vape, and each time that pressure change is registered, there's a bit of logic in some of them, not all of them, but some of them there's logic inside that says, right, okay, you've had X amount of puffs, and I'm done. And that's when you get these blue flashing lights on them, and that's when folk just chuck them out because they refuse to work. Some of them, it's based on the voltage of the battery. So anyone that knows how lithium batteries work, you really don't want to fully discharge them. They don't like being fully discharged. Neither do they like being overcharged. So basically, when these hit a certain voltage, there's a logic IC, a chip inside the vape that says, right, batteries at the minimum level and you're done, and you can't puff on it anymore. It refuses to work. So again, that gets chipped out the car window or thrown in a bin, and it's still got a lithium ion battery inside it that can be recharged and reused. So basically these things they're being thrown away like cigarette butts. That's how people are treating them. And as I said, there's a decent wee battery in that can be used to power other equipment. So what I'm going to do now is I'm going to start tearing the bar down, just to let you see how it's done. I'm not going to go through stripping them all down. I'll strip one down just to let you see the battery. What we're going to use to construct the battery pack is, this is a bit overkill. You can buy these charge boards or charge controllers off the internet, and they're cheap as chips. You're talking pennies, maybe 75 pence each, something like that. Some of them are more involved than others. This one's just got a single USB-C port. This one's got a USB-A and a USB-C, so you can charge this up with the USB-C, and you can plug in normal USB-A devices into that. What I'll do is I'll just kind of zoom in and let you see a bit closer what these things look like. So basically you've got your USB-A, so you can power LED lights on it. You can plug a phone charger into it to charge a phone, and you've got a USB-C port here which you can use on this device to charge. I'm not 100% sure, but I think you can charge and discharge at the same time with this board. So this is the one that I'm going to use today to build the battery pack. These little strips here, these actually break off. I'll just break one off for you. And basically these ICs here are kind of mini battery management systems. So these boards, they're quite clever. So again, if anyone that knows how lithium ion batteries work or lithium phosphate batteries work, you don't want to overcharge, and you don't want them discharging too low. So the logic on these boards basically controls how much current or how much voltage is allowed in and out of each cell, and this is like a protection circuit. So if you've got a battery that drops dangerously low, this IC will cut that battery off. It will stop any charging or discharging of that battery. I won't go into the full technical details of it, but basically it's a safety measure. These boards also have a kind of rudimentary charging control or battery management software built into them, or battery management system. So again, they won't allow the battery to discharge below a certain rate, and they also control the rate at which the batteries are charged. These will fit to the batteries just as a secondary measure. When the batteries are connected in parallel as well, these modules or these control boards will stop the batteries from being overcharged by each other. Basically, if there's no control, it's like turning a tap on. If there's no control, you can put too much charge into a battery, or too much current into the battery to charge between themselves, and it can damage the cell and possibly even set the cell on fire if you get a thermal runaway on the battery. So these devices here will stop that. They'll prevent that from happening, and kind of make the battery inherently more safe. So what we'll do is I will make a quick start, and I'll get the battery torn down. So first thing I'm going to do is, and I'll just bring you back out. I'm going to get myself some cleaning materials, i.e. a bunch of blue roll, because these things can get quite messy. There we go. And that's the first part off. To get the next bit out, I'll need to use this spudging tool. And they're really tightly packed in, these things. I think it might be coming. There we go. And there we have it. So that's just your empty case, and inside here we've got the lithium battery. And that battery has been taped in. I'll just cut the tape on it. And there we go. That allows us to get the battery out. So what we'll do with this battery is I'll just cut the wire on the top, on the positive side. And cut it on the negative side. So I'll just get rid of all this junk, all the stuff that we don't need. And as you can see, I've got all that juice on my hands. So basically what we're left with is a lithium ion battery, and what we'll do for this one is I'll bring in the microscope and you can have a quick look at this battery. I'll just start recording. So this battery is a 23350. That relates to the dimensions of the battery. It's a 6.48 watt hour, 3.7 volt cell. You've got your positive terminal here, and you've got your negative terminal here. So what I'll do is I'll just crack on and I'll get the rest of the cells taken out of the batteries, and I'll come back to you once I've got them all stripped out and laid out on the desk. So bear with me. Okay, so that's us got all the batteries out. I'm going to use 4 in this case. We'll make a battery out of the 4. Now, before we go ahead and use these batteries, it's very important that they're not overly discharged. If any of these batteries are below 2.5 volts, I'm not going to use it. They'll be discarded and properly disposed of. If the batteries are over 2.5 in the 3 to 4 volt range, then I'll be using those batteries. So it's just a simple check. All I'm doing is just checking the voltage on each cell. That battery has 3.7 volts, 3.69, 3.7 volts. So that's a good battery. So that can go on the good pile, which I'll stick here. I'll check this battery as well. That one's 3.92, so that's good. And this one here is if I can get the probes sat right. That battery is 3.5, so that's good. And this battery here is 3.8. So all 4 batteries are good. I'm not finished there, however. What I'm going to do is I'll use one of these charge controller, this wee charge controller here, and what I'm going to do is I'm going to charge all these batteries so they're all kind of at the same voltage. Again, you really don't want to be building a battery pack with batteries that are all different voltages, because basically what's going to happen is each of these batteries are, if they're wired in parallel in the battery, if this battery here's only at say 3 volts, that battery there's at 3.8 volts, that battery is going to fire current into that one so that they equalise. If there's no battery management system on that, that battery can absolutely hammer that battery with current, and it could damage that cell and possibly even set it on fire. So best practice with these things is to make sure that all the batteries are at a similar voltage, so the potential between each battery is kind of roughly the same, and you're going to have less likelihood of thermal runaway or anything like that. So what we'll do is I'll quickly make up a charge controller for these batteries. I may actually just put I can use the BMS. I can put these onto each battery, and then I can charge each battery up from there to make sure that they're sitting at the right voltage. So what I'll do is I'll crack on with that, and I'll get these fitted to each battery. So just quickly to let you see these BMS boards, on the back here you've got battery plus and B minus, battery minus. So these two pads here will go to the actual battery itself. This this side here to the positive terminal, this side to the negative terminal, and the actual power that will be effectively the power that you're going to use from the battery will come from these two here. So you've got your minus and your positive, or your negative and your positive here. So what I'll do is I'll fit this to the first battery, let you see how it looks once it's soldered on, and then I'll crack on and do the rest. Right, so first thing I'm going to do with the batteries here, what we'll do is can I zoom in a wee bit on that for you? First thing I'm going to do is I'm going to get rid of this Captain tape round about the terminals. I'll just bend that back and I'll just pick the tape off with my nail. If I can. And that's the module fitted. So you've got your positive terminal and you've got your negative terminal. Those are both soldered on, and there's a bit of mechanical grip there as well, and the only thing that's exposed are these two pads. Once I solder the wires onto these, I'll cover these with Captain tape as well, so the whole battery will be sealed. So what we'll do is I'll just crack on with the next two, and then I'll come back to you. Okay, so all four batteries now have a BMS installed. I'll just line them up so you can see them a bit better. So each one's got a positive and a negative, positive, negative. Same with that one, and same with that one. What I'll do now is I'm going to equalise the charge in all four batteries before I connect them all up in parallel. So what I'm going to do for that is I'm just going to solder on a GST connection on each of them, and then just hook them up. I'll just fit them to a charge controller, and I'll just put each battery on charge and get each one up to 3.7 volt, well, get each one up fully charged anyway, before I connect them all up together. That way when they are connected together, there shouldn't be much in the way of current flowing between each of the batteries. They should all be relatively the same. So I'll crack on with that. Okay, so the batteries are balanced. I've put a good bit of charge in them. I'll just plug that back in, and as you can see, they're about 3/4 full, the pack in general. So what I'm going to do is I'm going to unplug, and I'm going to do a quick test. I have a set of LED lights with a remote control, and what we'll do is I'll dim the lights and we'll plug in the the LED lights. And there we go. Success. There's a few different settings on this, so oh, there we go. I think we can just set it to, so that's it, set to white. So you get white, blue, green, red, yellow, pink. That doesn't look very pink, even off the camera it doesn't look that pink, but you get the gist of it. So that battery pack there will run those lights for quite some time. I'll just stick the lighting back on again. So that pack will run them for quite a considerable amount of time. So that's just one use. The other use can be used to charge phones, or I've got here a, let me see, what have I got that I can plug into charge. Everything I've got is USB-C. Let me find something to charge and I'll come back to you. Okay, so what I've got here is a, I'll just zoom in on that. I've got a wireless microphone receiver here. So what I'll do is I'll plug that into the battery pack and hopefully that should start charging. And there we go. I shall hold that up to the camera, hopefully it will focus. And there you go. That's the battery charging. So there you go, folks. There is absolutely no need for these things to go to landfill. It's an absolute crime that these things have been thrown in the bin when they're useful for other things. So that'll end the video. As I say, it was never going to be a commercial product. It's basically just a rudimentary battery or power bank that can be used to power different items. So we can run LED lights off it, we can charge devices, we can charge phones. There's all sorts we can do with this without throwing them back into landfill. So I hope you enjoyed that little series of videos, and I'll see you in the next one. Thank you.